Yes, good morning. Good morning, good morning, good morning. Good morning. All fine? All good? Yes? Yes, good morning, good morning, good morning. All good? Okay. Yes. So in last class, what we have done? In last class, what was done? We have started a mixture, I think, probably. Yes. Ice and water we need to start. Okay. So listen, for the ice and water means for the next thing. Actually, in case of ice and water, what are the thing that you are not sure that ice will melt or will not melt. Okay. Sometimes ice will melt completely, and sometimes there will be the partial melting. Okay. So we are not sure. So there are so many methods for these questions. Okay, and we have to adapt that method in which we are doing or okay, we are not going to do any mistakes. That method we need to consider. That is the one thing. Okay, so here in this one, okay, so many methods you can choose anyone. I'm going to take okay, tell one method. Okay, if you like that method, then you can subscribe to that method. Otherwise, you can have your own method. Okay, so for our method, we have some assumptions, and again, this is our method, so these assumptions also our assumptions. Okay, purely these are our assumptions. Means this is not the universal thing. Okay, just these assumptions are valid for our class. Okay, our method and our assumptions here. Okay, so what is the first thing that we can write? And you can write here, okay, that is the our assumptions. Okay, our method, our assumptions means this is not the fact actually. Okay, so we can say if you are having here in this one that okay, you got suppose ice as well as okay water, then we can say ice and water, because I'm not sure whether ice will melt or will not melt. Okay, so here I cannot consider one ice water. So common boundary for the ice and water we can assume. First, I will assume that ice and water will meet at 0 degrees Celsius. Ice and water will meet at the 0 degrees Celsius. After that, we can decide if both energy are same. Then we can say yes, energy released equal to energy absorbed. Sometimes what will happen, water will be having more energy. Sometimes okay, we'll see that ice require more energy. So three combinations will be possible. So ice and water, we can assume first of all will convert both to 0 degrees Celsius. Okay, then we can say if water steam is there, then you can say sir, water and steam we are going to take 100 degrees Celsius water, because they can exist at the 100 degrees Celsius. Okay, and then we can say here in this one ice and steam. So you can say for the ice and steam I can take either 0 degrees Celsius or I can take 100 degrees Celsius water. That is your choice, but I will prefer here also 0 degrees Celsius. Okay, in this case also I'm going to take the 0 degree Celsius. Okay, so first of all we are going to write this one ice and water. Okay, and these are the just assumption, not the answer or not anything. Okay, fact here. Okay, this is not the fact, just one assumption. So now we'll write the question, right? If first question that we are going to write here in this one, if 80 gram ice at 0 degrees Celsius mixed with 80 gram water at 80 degrees Celsius, mixed with 80 gram water at 80 degrees Celsius. And now in this one, they can ask possibly how many questions. Because first of all, they can ask about the temperature of the mixture. Second, they can say how much ice will melt. And third question, they can say how much ice will actually left in the mixture. And fourth question, they can say what are the water in the mixture. You know that whenever you will mix ice and water, whenever we are mixing ice and water, then temperature okay will get mixture temperature just we are mixing or after some time. Means this mixture process will take some time. So for some few minutes, for some time, temperature is not defined. If you dip the thermometer, you will not get one fixed temperature. temperature will be only fixed after achieving equilibrium. Okay, before that one, temperature will be undefined for a few times. It will keep on changing. Okay, so we are always talking about the once equilibrium is achieved. Okay, so this is the one question they ask, that whenever ice and water is mixed, okay, then what happens? Then we can say initially temperature will be undefined for some time, later on it becomes constant. Okay, as soon as you mix, it will not be the constant, it will take some time. If you're dropping the ice will not suddenly okay, will smelt, not like this. Okay, it will take some time. Okay, so now we can see in these questions, this side I'm going to write as usual. I have told to you ice, this is the 80 gram ice, and I have to put at the 0 degree Celsius, and then I can say this side I will be writing here, okay, your water, and this is the 80 gram water, and that I will write at the 80 degrees Celsius. And as usual, they will ask on all the questions. Number one, temperature of the mixture they will ask. Okay, that you have to find temperature of the mixture. Second thing we can say, we need to find here in this one, mass of ice melt. How much will melt here? Number three, we can say mass of ice in the mixture we need to find. And number four, we can say mass of water in mixture. Okay, we need to find mass of water in the mixture. Okay, so these are the few questions that we have to do here. So now we can say in this one we are going to assume first of all 0 degree Celsius water. Okay, so we can say this one will convert to 0 and this one also will convert to 0, and then we will equate the energy. So 0 ice to 0 water. 0 ice to 0 water is basically simply MLF, and here requirement of energy will be 80 into 80, that becomes actually 6400. This side we can say water will be coming from 80 to 0, and if water is coming from 80 to 0, then we can say here will be only ms delta theta. Okay, so we can say m is 80, s is 1 delta theta 80, so that actually becomes 6400. Now if you say, then you can say both side ice is demanding that if you give me 6400, then I will completely melt. I will completely melt and I will convert to 0 degree Celsius water. And water meanwhile saying that okay, I will supply 6400. It means here energy requirement was 6400, supply is also 6400, both are equal. And then both are equal, then you can say total ice will melt or will not melt. In this case, you can say yes, ice was asking for the ice requirement is only 6400 for the full melting. And this much energy is supplied by the water, so total ice will melt. In this case, full ice will melt. Okay, so now we can say here in this one, mass of ice that will melt will be the 80 gram. Full ice will melt here, 80 gram. We can say how much ice will be there in the mixture. Okay, how much ice will be there in the mixture? So we can say in this case, okay, there will be no ice left because total ice already melt, so there is nothing left. Okay, there is no ice left in the mixture, total ice converted to water. So if I'm asking how much water will be there, you can say from this side 80 gram coming and from this side 80 gram coming, so total actually becomes 80 from this side, 80 from this side, total becomes your 160 grams. So we can say it becomes your 160 gram is the total water. Now we can say finally actually what will be, you will be having that from here 80 and from this side 80, so we can say total is the 160 gram, 0 degree Celsius water. Any energy left in the mixture? Any energy left in the mixture? There is no energy left. We can say required energy equal to supplied energy. Okay, whatever ice was demanding, water is supplying that energy. There is nothing extra left in this one. So we can say what will be the temperature of the mixture in this case? Your equilibrium in this case will move forward or backside, because whenever both are same, both energy are same, then your equilibrium will not move. It will stay at the 0 degree Celsius. So what will be the temperature at 0 degree Celsius? Temperature at 0 degree Celsius. I mean, what is the temperature of the mixture? Temperature of the mixture is going to be 0 degree Celsius. Your equilibrium will not move. And now we can say whenever you get the both side energy same, whenever both side energy is same, then your equilibrium will not move. Temperature of the mixture is going to be 0 degree Celsius. Okay. So whenever both side energy are same, you can say temperature of the mixture will be all the time. Okay. All the time I can say 0 degree Celsius. Yes. Ready for next? Can you do the next question now? Finished? Yes. So now we got that there will be the three cases actually. Okay, first case here we can say that both side energy are equal. And if both side energy are equal, then we can say 0 degree Celsius full ice will melt. Full ice will melt at 0 degree Celsius. That's it. Okay. Next case will be that water. Okay, water will be in this case. Yes. So next case will be that ice will be demanding only 6400 and water will be supplying huge amount of energy. Water will supply 7000, 8000. In that case, what will happen basically? Your ice will melt as well as some extra energy will be left in the mixture. Some extra energy will be left in the mixture. Okay? Can we do the next question? Okay. And what you are doing, Vikasita, here? Okay. Yes, ready for next. So this equal condition, I hope we got. Okay, so now we are ready for the next question, and this part will remain same. So I'm just going to means these 4 questions will be as usual same here. I'm going to just copy here and then taking the next one here. Okay, so now we got next question. They will say like we got here ice. Okay, they will say 20 gram ice. We are mixing it minus 20 gram ice at the minus 40 degrees Celsius. If both are not equal means both are not equal, we'll do the case. First we'll do the questions in which equal things are there. Either equal, either this side energy more, either this side energy more. These are the 3 cases going to happen. 3 cases will be there, either equal, either this side more, either this side more. So right now I'm telling only equal cases. First we'll get confidence in the equal. Once you say yes, we can do any question on the equal, then I will move to the next part. So we can say here 20 gram ice at minus 40 degrees Celsius is mixed with 40 gram water at 50 degrees Celsius. They will ask again as usual these 4 questions. What we can say, first of all we are going to assume here 0 degrees Celsius water, and then you can say this will be converted and this will be also converted here. So now we can say first of all in this one ice 0 ice will be converted to 0 ice will be converted to 0 ice will be converted, means minus 40 ice will increase the temperature. So first of all ms delta theta, and then 0 ice will be converted to 0 water. So we can say this will be the MLF. Again here, what should be the value of S? What means what I have to take for S? S 1 or half? What should be the value of F? S specific it 1 or half? In this case 1 or half. Whatever you say, I will take that. Yes. But I am confident that you will tell the correct value. 1 or half. Because we need to calculate this thing. Meanwhile, you are answering. This side I can write only ms delta theta will be there. Because water will be decreasing temperature from 50 to 0. 50 to 0. Yes. What should be the value of S here? Initially, temperature of ice will be increasing from minus 40 to 0. Yes. And then we can say MLF will happen. So people are saying answer as half, so I'm going to take here half. But in YouTube no one answer. Only in the app people have answered. I think YouTube people are just coming for the enjoyment. In live YouTube no one answered, and this side in the app almost I got the messages. So yes, this is the half. Lag is there. Okay, no problem. Lag is there. So we can say mass will be 20, S is half. Delta theta will be 40. This is the 20 into 80. 20 into 80. Yes, lag might be there because of internet connectivity is not so great. So we can say this becomes 10, so it is the 400 plus we can say this is the 1600. Actually this becomes 2000. And then we can hit 40 into 1 into 50. So we can say this is also 2000. Both energy are equal. Ice demanding 2000. Demand for ice is 2000. Water is saying take 2000. In this case, full ice will melt or will not melt. Ice demand is 2000. Water saying take 2000. What will happen? You can see yes, full ice is ready. Ice is ready to melt. Ice will say I will melt. So full ice is going to melt here. Full ice will melt here. Yes. So we can write here in this one, total 20 gram will melt. Any ice will be left in the mixture. You can say sir, total ice melt means nothing is left in the mixture. Nothing is left in the mixture. So we can say 0 gram will be left in the mixture. How much water will be there? You can say sir, water will be actually that already you have some water of the 50. So this 50 water is coming to the 0 degree Celsius water. And then you can say sir, this ice also. This ice is okay, here melting of ice is also happening, so that will be converted to water. So total water we can say from this side 20, from here 40, it becomes actually 60. Are 60? How you are calculating here? This one, this is the yours 40 and 20. How you got extra 10 from your fridge? Taken 10, already mixed. Right? I got 70. Don't do like this. From here 40 and from here 20, so we can say this one is actually your 70 gram here, okay? And now we can say whenever, okay, equal things are there. Energy are equal, means it is demanding, its demand is, okay, here you can say demand is only 2000, supply is also 2000, both are balanced. Your equilibrium is not going to move in any of the direction. Equilibrium is not going to move in any of the directions. So we can say temperature of the mixture is going to be, temperature of the mixture is going to be 0 degrees Celsius. So we can say this is going to be 0 degrees Celsius here, okay? Now can we go for next one? Next question waiting for you. Okay, so these are the two questions that gives you idea that if anywhere we are getting the equal energy both sides, how we will proceed. Means temperature of the mixture is going to be 0 degrees Celsius. And yes, can we go for next? Now we'll see that next questions in which ice will be demanding 2000 and water will say that I will give you 3000, I will give you 2500, I will give you 4000, I will give you more than that, okay, whatever is your demand, I will supply more than that. So in that case, what will happen? Total ice will melt or will not melt? Are sir, how 70? Are where are written 70? Oh, 70 not, oh. This is the by mistake, okay? Actually, someone told 70, okay? So, okay, by mistake 70 written, okay? Someone was saying 70 here, okay? I just took that as the joke that how you got extra 10 gram from fridge. So, okay, by mistake written. I actually write whatever you are saying, okay? Yes. So, clear, 40 plus 20 is the only, 40 plus 20 is the 60, not the 70, okay? Someone told, so I heard in that one. Now, we can go for next question, okay? In that one, demand will be 2000 and, okay, it is water will be supplying more energy, okay? So, total ice will melt, okay? And then ice and water, there will be some excess energy will be there. And when some excess energy will be there, what is going to happen? Because excess energy will make the mixture hot. Excess energy will make the temperature, will make the mixture hot, means temperature of the mixture will increase, okay? So, right, next question. Next one you have to write, okay? Because I will solve on this slide only. Right, 20 gram ice at minus 40 degrees Celsius. You can write the next question. 20 gram ice at minus 40 degrees Celsius. 20 gram ice. I will be just, okay, I will edit here. 20 gram ice at minus 40 degrees Celsius is mixed with 40 gram water at 80 degrees Celsius. 40 gram water at 80 degrees Celsius. 80 degrees Celsius. 80 degrees Celsius, okay? So now we can say, okay, in this one, 40 gram water at 80 degrees Celsius, we are mixing with the 20 gram minus 40 ice, okay? So we can say this side calculation will be as usual, that is, okay, means there is no change in this calculation. This calculation will be the same calculation, okay? Just here changes are there. And what are the changes here? You can say, sir, 40 into 1 means ms delta theta. Temperature becomes 80 right now. So you can say, sir, this is going to be 3200. So 2000, that side ice is asking this, give me 2000, I will melt. And water is saying, no, I will give you 3200. Okay. So 100% ice is going to melt without any doubt. Yes. I think in this part you don't have any single doubt that ice will melt or will not melt. You can say, sir, ice is going to 100% melt. In this case, full ice will melt. Okay. So now we can say here in this one, complete ice is going to melt. There is a 20 gram ice will melt, and we can say any ice will be left. You can say no ice will be left in the mixture. There is going to be 0 gram ice. Nothing is left in the mixture. Total ice will melt. Okay. How much water will be there? You can say total ice will be melting in this case. So from this side 20 will be coming, from this side 40. So total water is going to be how much here? 60 gram. Okay. 60 gram water will be there. Okay. Now we need to find, sometimes they are asking what is the okay, how much water content will be there. We can say water content is going to be your 60 because we know total ice is going to melt. Now if you say, sir, in this case, what is the thing here? Energy are not equal. Okay. Ice is saying that I need 2000 for the melting, and water is saying I will give you 3200. Okay. So you know this side energy is more, means mixture is having some excess of energy. And when I have told you, when okay, excess of energy is there, of course temperature will increase. So we can say how much is the excess of energy. You can say, sir, in this case Q extra is going to be how much? 1200 calories is the excess energy. And you know, wherever you have excess energy means temperature. Okay. Temperature is going to increase. Okay, mixture is going to be hot. So now we can say this Q extra increases. Q extra increases temperature of mixture. Q extra increases temperature of the mixture. And for the temperature change, everyone knows that we use the formula of ms delta theta. So I will write this thing here. Ms delta theta is going to be this 1200, and then you can say, sir, mass. Total mass of the mixture in this question, that is the 60 here, S1 and delta theta, that becomes here 1200. So you can say, sir, this is 10 cancelled, and finally I can write delta theta will be 20 degrees Celsius. Means in this case, temperature of the mixture is not going to be 0, it is going to be 20 degrees Celsius because of the excess of energy, because water was ready to give extra energy. Demand was only 2000, but water supplied 3200 calorie. Okay, because of that only temperature will increase. But we know one thing, that total ice will melt in this case. So these are the only 4 questions that they can ask here. Yes. So if this side energy is more, then you can see here in this case your equilibrium is going to shift in the forward direction, and because of the temperature will increase. Because of the temperature will increase, equilibrium will be shifted in the forward direction. Is temperature will increase. Temperature will increase because of the difference of the energy. Here difference of the energy, excess of the energy is because out of 3200, 2000 it will consume for the melting purpose. Out of 3200, 2000 is used for the melting purpose. So remaining energy will be used for the increasing temperature. Remaining energy is used for the increasing temperature. I hope we got this thing. Can we go for the next question now? Ready for next? Yes. And listen, again, I am saying, if you are going to get, suppose, because mass can be given in the kg, mass can be in the gram. Mass can be in the kg as well as gram. Okay. So for the mass, okay, if it is given in the kg also, we will solve only in the gram, just to avoid calculation. Just to avoid calculation, we can do in the gram. Okay. Like if I say you have this much sample, you have 100 kg, 500 kg, or 1000 kg of ice, and so much water is there. Okay, for the experiment I will take just a few grams of ice and few grams of water. Like if you have, suppose, okay, 5 kg of ice and 5 kg of water, then you can say we can do experiment not by utilizing total 5 kg of ice or 5 kg of water. We can just take 5 gram ice and 5 gram water, and whatever the result will be here, same result is valid for the 5 okay, bigger amount also. I hope you agree with this thing. Whatever conclusion will make with the smaller amount, same thing will be valid for the bigger amount also. So if they have given in the kg, better we will take in the all the calculation in the gram, because you are okay in the gram, you are not going to do mistakes. When kg comes, then there can be some unit conversion or something, so we might do the mistakes. Okay, so if kg is also there, we will solve question by assuming it in the gram. We will solve whole question by assuming it in the gram. Later on, we can just take care of the units. Later on, while answering the question, we can take care of the units, that okay, kg was given, so we can answer in the kg. That's it. Okay. So like next question I will be taking here, and as usual, these questions remain same. So I'm going to copy here, and then we can write. We'll clone this one and write 5 kg ice Next question. 5 kg ice at minus 40 degrees Celsius. They can give some other temperature, minus 10, minus 20. Okay, I'm taking here for the easier calculation. Is mixed with 10 kg water at 80 degrees Celsius. 10 kg water at 80 degrees Celsius. Okay, method will remain exactly same. There will not be any single change in the method. Only thing that we can say, whole question we will solve in the gram or kg. Complete question we are going to do in the kg or gram. Complete question we will have to do in the gram, and final answer we will write in the kg. That's it. Okay, final answer will write in the kg. That's it. If you are suppose writing for the board examination, then don't take this method. Okay, because in board examination there is the marks for the your solution also. So this solution may not be the correct solution unit wise, because I'm not going to solve in the kg. I will be solving in the gram. But for NEET, no one is going to check your solution, what you did. You got correct answer, that's it. Okay, we have to get correct answer. We don't have to do any mistake. We have to do the calculation fast. That matters. Okay, stepwise marking not there. So now we can say, I will just convert into 0 degrees Celsius. Okay, and this side as well as this side. Okay, so I can say first of all here ms delta theta plus MLF. Okay, nothing is new because I'm going to take only 5 gram. Listen, out of 5 kg, I'm doing this question by considering 5 gram and here 10 gram. So don't ask me, sir, you are putting value of specific heat in calorie per gram. Why I am putting in the calorie per gram? Because I am solving complete question in the gram. Okay, so don't say, sir, this value is not correct. This calculation is wrong. I know. Okay, but I am taking in the gram. Again, I'm saying I'm taking in the gram. Okay. Otherwise, okay, what will someone will say, sir? Okay, someone will directly jump to this part of the video and then say, oh, wrong. Okay, so this is not the wrong thing. Delta theta, I can say 40 plus I can say 5 into 80. So we can say this becomes here how much? 20 into 500. So we can say 100 plus 400. That is the 500 this side. Okay. Again, I'm saying this is okay. Actually, here should be 500 into 10 power 3. It should be the 500 into 10 power 3. But I am not writing. I am not considering because the 10 power 3 will be cancelled from both sides. This side also I will write ms delta theta. So we'll say, sir, this is the 10 into 1 into 80. That actually becomes how much? Your 800. 10 power 3, 10 power 3 will be cancelled, not taking. Okay. You know this is okay. Ice is demand. Demand for the ice is that I need 500. What I say, take 800. And melt. I will say, yes, I will melt by taking 500, but why you are giving me this excess energy? Then what else with the excess energy? We will increase the temperature. So we can say in this case, what the excess energy here? Q extra is going to be here. You can say 300 calorie is going to be excess energy here. Okay. So now we can say how much water will be there. We can say from this side 10, from this side 5. So this is the 15 unit. Okay. I'm just writing the unit. Okay. 15 unit because I know that I'm doing in the gram. Later on answer I have to put in the kg. So you can say this is the excess. Excess energy here, and this extra energy is going to increase the temperature. So we'll be writing ms delta theta equal to 300. So mass I can use 15. Again, this is the 15 gram I am taking. S will be 1 into delta theta, so equal to 300, and delta theta we can say how much here? 20 degrees Celsius. Okay, so we can say temperature change 20 degrees Celsius. Total ice will melt. How much ice will melt? Now here answer we can write in the kg, 5 kg. Okay, here we can write 5 kg. There will be no ice left, and total water we can say this is the 15 kg. Okay, so if it is coming in the kg also, will you be confused or will you do any calculation mistake? No, we will simply doing in the gram. Okay, only thing answers. Okay, of course you have to be alert that answers we have to put in the kg. I hope this part is also clear. Can you move forward? Next question. Next thing. Yes. So next case that will be quite interesting here. Ice will demand 500. Ice will say I need 500 to melt completely, and water will say I don't have 500. I have only 100. I have only 200. I have 300. I have 400. Means that energy of water will be lesser than the demand. So if energy of water is less than the demand, then what will happen? If energy is less than the demand, energy of water is less, then you can say total ice will not melt. But ice will say, I need 500 for the melting. If you give me 500, then only I will melt. Otherwise, I am not going to melt. So water will say that whatever I have, okay, with that energy you can melt whatever, okay, 10 gram, 5 gram, 2 gram, okay, whatever, okay, but okay, at least melt. So with that remaining energy only it is going to melt, okay. So total ice will not melt. And you know, when total ice will not melt, if ice and water both are there, and if in any question ice and water both are there, a mixture contains ice and water both, what can be the temperature of the mixture? If ice and water both are there, then what can be the temperature of mixture? You can say, if ice and water both are there, temperature of mixture is going to be 0 degrees Celsius, because both can coexist at the 0 degrees Celsius. Both will coexist at the 0 degrees Celsius. If I say mixture contains ice and steam, then you can say ice and steam, then it can be 100 degrees Celsius, because ice, no, not ice, it means water and steam. So you can say water and steam can coexist at the 100 degrees Celsius, and ice and water coexist at the 0 degrees Celsius. So we'll write here, next question. Now we are ready. Okay, so write question first, because in the same question I have to edit here. So 5 kg ice at minus 40 degrees Celsius . 5 kg ice at minus 40 degrees Celsius is mixed with 3 kg water at 60 degrees Celsius. 3 kg water at 60 degrees Celsius. 3 kg at 60 degrees Celsius. Find. And now, as usual, we have to find all the things that we are finding here. Fine. So you can see, sir, this side process remain exactly as it is. There is no change in this process. Okay, exactly it is. And this side we can write ms delta theta. I am doing again. Okay, when kg is given, okay, kg is given, you are going to do full calculation by considering it in the gram, and there is no problem. Okay, there is no mistake, because out of that big sample we can take a small sample in the lab. Okay, we are doing experiment always with the small amount. So we can say I will take here 3 into 1 into 60. So water is only able to supply 180 while demand is 500. Okay. In this case, one thing is sure, that total ice will not melt. Okay. Ice is asking that give me 500, then I will melt. Water is saying that I can max to max supply 180. 500 is not in my capacity to supply this much energy. Only 180 I can supply. With 180 you want, okay, then melt. If you don't want, then no problem. Okay, so we can say in this case 100% there will be the partial melting, and if that the partial melting means there will be the ice also. If partial melting, there will be the ice as well as water. Okay, there will be the ice as well as water. Ice will be also there as well as water. And ice and water, then what is the temperature of the mixture? Temperature of the mixture, if both are there, because in these question, okay, most probably temperature of the mixture is going to be 0 degrees Celsius. So we can say both are there, temperature is going to be 0 degrees Celsius. Okay, so I can say temperature I got 0 degrees Celsius, because we are able to figure out that total ice will not melt, partial melting will be there. And whenever partial melting is there, then we can say half, okay, full ice will not melt. So ice, water, both will be there. Now some people will ask, how much will melt then? You might be thinking, sir, if total is not melting, then how much will melt? And here I am spending some more time, because in this one only people are doing the mistakes. Okay, so I'm taking 1-2 minutes extra so that we can easily absorb this concept. Because once you are getting this thing, then all questions of mixture variety will be over. With mixture variety, we are just, okay, dividing into three parts. Equal, this side more and this side more. So equal means, temperature is going to be 0 degrees Celsius. If this side more, then temperature will increase. With the excess of energy, temperature will increase. This side, then partial melting will happen. And that thing we have to find. Okay, so listen here. We can say with the 180 energy, okay, when ice, water will be having discussion with the ice for the melting, then ice will say that I will be only ready to melt if I am at the 0 degrees Celsius. First, you have to bring me at 0 degrees Celsius, then I will be ready for melting, because melting of ice will only start at 0 degrees Celsius. We know this thing? Melting of ice will start at 0 degrees Celsius or any other temperature. 0 degrees Celsius. Under normal condition, melting of ice starts at 0 degrees Celsius. Are Sanjana Reddy, from where you got 4 degrees Celsius? Ice will melt at the 0 degrees Celsius from the our childhood. We know this thing. 0 degrees Celsius, ice will melt. No? Yes. Ice will be ready to melt at the 0 degrees Celsius. What ice will say in this case, you can say, okay, that out of 180, first of all, you have to bring it at the 0 degrees Celsius. So to bring this ice to 0 degrees Celsius, 100 calorie will be consumed to increase the temperature. Out of 180, 100 is consumed to increase the temperature. Out of 180, 100 energy ice is demanding just to increase the temperature. With that 100, ice is not going to melt. With 180, out of 180, 100 only the demand is to increase the temperature. So you will say, sir, how much energy left for the melting purpose? Because out of this, if I say out of 180, 100 energy is used for increasing temperature. After increasing temperature, once ice is coming to 0 degrees Celsius, then only I can talk about the melting. So we can say energy left for melting purpose. So energy left for melting. How much energy is left for melting? Out of 180. Out of 180, 100 is consumed. 100 is consumed for the increasing temperature. So we can say only 80 is left for the melting purpose. 80 calorie only left for the melting purpose. Okay. Again, I am saying here, I am doing full question in the gram. I am doing full question in the gram. Answers I will write in the kg. That's it. Okay. Whenever kg is there, don't confuse yourself. So now we can say with this amount, how much ice will melt. So we can use MLF equal to 80. So M we can write here in this one 80. LF is also 80. So we can say 1 unit ice. 1 unit ice will melt. 1 unit ice will melt in this case. Unit means it can be the, I'm doing in the gram, but it will be the kg. So 1 will be melting temperature will be 0. Mass of ice will melt 1 kg. How much will be left in the mixture? You can say, so out of 5 kg, only 1 kg will melt. So we can say 4 kg will be still left. And they will ask how much water. You can say already 3 kg water was there. 1 kg coming from this side. And if 1 kg coming from this side, then total water will be how much here? Total water we can say 3 plus 1, that is the 4 kg. Okay. So in the mixture we'll be having 4 kg water as well as 4 kg ice. 4 kg water and 4 kg ice. I hope this one is clear now. Can we do some more questions? Some more questions, yes? Okay, ready? Okay. Let's do. Okay. So now we're having next question here in this one, and in the next, as usual, this part is going to be same. So I will just, I will clone this part and then we'll be writing the next question. I hope this one is clear to you. Yes? This is clear? Okay. Okay, Maruti, very good. Chilling the life. Okay. So now we'll be doing the next question. Yes. So we can say here in this one, next question is, waiting for you. We got ice is there, there is the, suppose 40 gram ice at minus 20 degrees Celsius. Okay, 40 gram ice at minus 20 degrees Celsius. And this side we got, okay, this side water, okay, and we are having 20 gram water at 90 degree Celsius. Okay, 20 gram water at, okay, I can take here, okay, 90, or I can take better 80 degree Celsius. Okay, 20 gram at the 80 degree Celsius. Okay, yes. So now we can see in this one we have to figure out what will actually happen here in this one. Okay, yes, ready? Can we do the things? Okay. Okay, you want to change the value, you can change. Okay, you can take anything here. Okay, no problem, you can take here. Okay, suppose 40 gram at the 50 degrees Celsius. Okay, now you can do the question. Okay, will you do the question now? Yes. Okay, so now we can say we have to assume 0 degrees Celsius. Okay, and you can say it will be converted, this will be also converted. So I can say first of all ms delta theta as well as MLF, and here we can write simply ms delta theta. M is 40, this is the half into 20 plus 40 into 80. You can say, sir, this becomes here 400 plus we can write this is the 3200. So this becomes 3600 this side. I'm not writing the, okay. And you can write this side, I am 40 into 1 into 50, that becomes here 2000. Okay, you know 100% this side energy is more, means total ice will not melt. And when total ice is not melting, you can say in that case ice and water both will be there, so temperature 0 degrees Celsius. Now we can say out of 2000, 400 is used for the increasing temperature, because ice will be ready to melt only at the 0 degrees Celsius. Only at the 0 degrees Celsius. Okay, so 400 is consumed for increasing temperature. So we can say energy left for melting. So energy left for melting, we can say in this case, okay, melting will be actually here we can say 1600 calorie will be left for melting. Then we can write ml, okay, mlf equal to 1600. So you can say m becomes 1600 by 80, which actually becomes here, if you say, then we have your 20 gram ice. Okay, so now we can say ice will melt. How much ice will melt? You can say 20 gram will melt, 20 gram will be left, and total water we can say will be the 40 plus 20 melt, so it will be the 60 gram water. Okay, yes, completed. Over. Can we do the next things? One more question. One more. Okay. Right then. Okay. Right. One more. Again, we are having these things common. So in ice and water, actually all the cases we have covered. Now we'll take some question on the ice and steam. So right, 5 gram steam mixed with, not 5, means 5 gram ice mixed with 1 gram steam. 5 gram ice mixed with 5 gram ice mixed with 1 gram steam. Okay, and whenever you know temperature not given, all the time by default we assume temperature to be for ice 0 and for steam, okay, for steam we take temperature 100. Okay, temperature not given by default. Okay, so we can say we'll assume 0 degrees Celsius water here, and we can say from this side it will be the MLF only. But this side, if you write, then 100 steam will be coming to 100 water. 100 steam, first of all, will be converted to 100 water. So there will be the MLV, and then we can say MS delta theta. M will be 5 into 80, so you can say, sir, this side it becomes 400, and this side M into LV will be 540, plus I can write 1 into S will be 1, because temperature of the water we are decreasing from 100 to 0. So temperature of the water change, so we are writing 1 into 100. Yes, this is the 640. So we can say this side energy is more. How much is the Q extra? You can say, sir, Q extra in this case is 240. That will increase the temperature. From this side 5 gram ice, and from this side 1 gram steam. So we can say total water will be 6 gram 0 degrees Celsius water with excess energy of 240, with excess energy of 240. Okay, we have 6 gram 0 degree Celsius water with the excess energy of 240. With this ice, this steam will be coming to 0 degree Celsius water by supplying 640. This will be converted to your water by taking 400. So now we can say here in this one, this will increase the temperature. So Ms delta theta equal to, we can say, to 40 here. Mass is 6 into 1 into delta theta to the 240. So delta theta becomes here 40 degrees Celsius. Okay. So I guess the temperature of the mixture becomes 40 degrees Celsius. Mass of ice that will melt, we can say total ice will melt. So it is the basically your 5 gram. And how much steam will be there in the mixture? 0 gram. Total water will be the 6 gram. Okay. And we can say number 5. Mass of steam condensed. How much steam will condense? So you can say total 1 gram steam will condense. I hope this is clear. Yes. Sometimes what will happen when you will be solving the question of ice and steam, your temperature will be more than 100. And if any of the temperature is more than 100 possible, temperature of water can be more than 100. Temperature of the water cannot be more than 100. And if temperature cannot be more than 100, then what will happen? Maximum temperature you have to answer 100 degrees Celsius. In that case, maximum temperature, okay, you have to answer temperature of the mixture only as 100 degrees Celsius. Total steam will not condense, okay. Suppose answer is coming 140 degrees Celsius. I will put 100 degrees Celsius, okay. It means total steam will not condense, okay. But suppose a huge steam is there, then total steam will not condense, okay. So ice and your water and steam both will be there. So it's water and steam that can exist max to max at the 100 degree Celsius. Suppose you got 240 degrees Celsius, answer you have to put 100 degrees Celsius. You have 300 degrees Celsius, answer you have to put 100 degrees Celsius. Maximum temperature of the water can be 100 degrees Celsius. In that case, total ice will not condense. That we will do in the next class. Up to this, it is clear. Up to this, everything is clear here. Yes. Okay. So bye. Do all the things related to mixture. You will be able to do the things. Okay. And then, okay, next we will finish the things. It will be, okay, over. Calorimetry will be over. Okay. Means most of the 80% part is over here. Okay. Bye. Okay.